Hello everyone, my name is Ankit Verma. Today we will start our next topic, that is TCP/IP model. So we are aware about the OSI model, that is the open source interconnection model, in which we have the 7 layers. So now we have the 7 layers of the OSI model. So the first layer is the physical layer, second is data link, third one is network, fourth is transport, fifth is session, sixth presentation, and last one is application. So in the research, OSI was the first model. There was proposed that we have the 7 layers and we will fit multiple protocols, but at the time of implementation, OSI was a failure. Why? Because there is no use of session layer, there is no as such use of presentation layer, and data link layer task is already done by the transport layer. So that's why we have 3 layers which was not of the use. So that's why we have developed the next model called the TCP/IP model, and TCP/IP was the first implementation in the market and comes before the OSI model. So the presentation layer, session layer and data link layer was not of the use in the OSI model. So that's why we have merged up the layers of the OSI model and provide them in the TCP/IP. So first of all, we have linked up the physical and the data link layer and provide the name as the host to network layer. Next we have the internet layer, which is the replacement of the network layer. Then we have the transport layer, which is same as the OSI. At last we have the application layer, which is now the combination of all the 3 layers of OSI, that is application, presentation and session layer. Now this one is our TCP/IP model, and you can see that in the TCP/IP we have the 4 layers, and in the OSI we have the 7 layers. So the main difference between OSI and TCP, the OSI has 7 layers, TCP/IP has 4 layers. OSI is used for the telecommunication and TCP/IP is used for basically the internet purpose, and OSI was the proposed work, but TCP was the first implementation before the OSI model. So let's now discuss about the layers of TCP/IP. So first of all, we will discuss the host to network layer of TCP/IP model. So the host to network layer is basically used for the connectivity purpose. There is no SH protocol used in the host to network layer. So that's why there is no SH explanation available for host network. Now the next layer comes the internet layer, also called as the network layer. So next layer of TCP/IP is the internet layer, whose main protocol is IP. So the main protocol of internet layer is IP, that is the internet protocol, or also called as the internetworking protocol. Internetworking protocol, it is unreliable and connectionless protocol. It is a transmission mechanism which is used by TCP/IP protocol. It provides best effort delivery. That means the data comes as it is sent by the IP. That means there is no error checking and correcting by the IP. That means the data is directly sent to the next layer. The next one, it is the host to host protocol. And the next and the main feature of IP, that is it transports data in packets called the datagram. Now we have 4 more protocols, that is ARP, RARP, ICMP and IGMP, which are used by IP. IP protocol is using all these 4 protocols. So IP is using 4 protocols. The first one is ARP, second is RARP, next is ICMP, and the last one is IGMP. Well, these are the 4 protocols which are used by the internetworking protocol of the internet layer or the network layer of TCP/IP. Well, about the ARP stands for address. So we have the 4 protocols, that is ARP, RARP, ICMP, IGMP, which are used by the internetworking protocol IP in the TCP/IP protocol. Now first one we have the ARP. ARP stands for address resolution protocol. ARP is basically used to find out the physical address of a node when logical address is given or the INET address is given. Next we have the ARP, that is the reverse address resolution protocol, which is the reverse of ARP. As it is the reverse of ARP, so it is used to find out the INET address of host when the physical address is given. Next protocol is ICMP, that is called the Internet Control Message Protocol. Well, ICMP is basically for the error and the query purpose. Whenever we have any error and query, it's directly report to the sender. So the main purpose of ICMP, that is Internet Control Message Protocol, is for the error reporting purpose. And next we have the IGMP, that is called the Internet Group Message Protocol. It is basically for the bulk communications. Example, we want to broadcast anything, we want to broadcast a message. In that case, we need the IGMP protocol. With the help of IGMP, we can send the bulk messages to the various receivers. So the IGMP facilitates the simultaneous transmission of a message to the group of recipients. So next layer we have the transport layer in the TCP/IP model, in which we are having the three main protocols. The first one is TCP, secondly we have the UDP, and the third protocol is SCTP. So now we will first cover the TCP. TCP stands for Transmission Control Protocol. Now the Transmission Control Protocol is a very important protocol of the TCP/IP model. The first main task of TCP, that is Transmission Protocol, is that it is reliable stream support protocol. Now here we cover the two main things. That first one is reliable. Reliable, that means we can use anywhere wherever we want. So the first main thing of TCP, that is reliable. The next one we have the stream support. Stream support, that means somebody is reliable as well as connection oriented. So that is the combination of reliable as well as the connection oriented. So we also call it as the connection oriented protocol. So in the TCP we have covered the two main things. That is, first one is reliability and second one is the connection oriented. So we can also take the example of the optical fiber media, that is the example of TCP, that is connection oriented. Then the next one, TCP divides stream of data into small units, that is called the segment. So the segmentation part is done by the TCP protocol. Now segments include two types of serial number. So first one is we have the serial number, that is for the reordering purpose, and second one is the acknowledgement number, that is for segmentation. So the first one we have the serial number, and that serial number is used for reordering. And the next we have the acknowledgement number, and this acknowledgement number is used for segment received. And the last main point of transmission control protocol is the data delivery is guaranteed. That means, for example, we are having the connection oriented. In that case, the data should surely be received at the receiver side. So the data delivery is guaranteed. So that is all about the transmission control protocol. Now the next protocol we will discuss is the UDP, that stands for user datagram protocol. Now the UDP, that is user datagram protocol, is completely different from the TCP. As the TCP is connection oriented, the UDP is connectionless. So UDP is the connectionless. That means if you are taking the example of the Wi-Fi, that is the example of UDP. So any wireless media comes into the UDP protocol. Then the next one, it is the process to process protocol. As the TCP is reliable, UDP is non-reliable. In the TCP, data delivery is guaranteed, but in the UDP, that is user datagram protocol, the data delivery is not guaranteed. So the last and main point of UDP is it adds only port address, checksum error control, and the length information of data. Now the next protocol we have the SCTP, that is called the Stream Control Transmission Protocol. Well, obviously in the TCP and UDP we have the few main features as well as the few main disadvantages. So SCTP, which is called as the Stream Control Transmission Protocol, is the combination of TCP and UDP, but only the advantages. So if we have taken the advantages of TCP and UDP and they are added to the SCTP. So we can say that SCTP combines the best feature of TCP and UDP, and it also supports the newer application just like the VoIP, that is the voice over internet. So that is all about the transport layer. In the transport layer we have discussed about TCP, UDP and SCTP. TCP for the connection oriented, UDP for the connectionless, and SCTP, that is the combination of TCP and UDP. So now we will discuss our next layer, that is the application layer, which is the fourth one in the TCP/IP model. So the first protocol in the application layer is SMTP. SMTP stands for Simple Mail Transfer Protocol. When we want to send any of the mail, then we use the SMTP. In sending the email or transferring the email, the SMTP is used. The next protocol is FTP. Now FTP stands for File Transfer Protocol. For example, we want to send a particular file from one host to another host. In that case, we use the FTP protocol for the file transferring. The next protocol we use the HTTP. HTTP stands for Hypertext Transfer Protocol. Whenever we want to design any web page, for example, we want to open a particular web page. For example, we want to open www.facebook.com. In that, we will see as the prefix as HTTP or HTTPS. So, hypertext transfer protocol is used for opening any web page. There is one more protocol, that is HTTPS, which is called the Hypertext Transfer Protocol Secure Line. For example, you want to open a particular website, in which website will provide a username and password, then the protocol uses HTTPS. The next protocol used is Telnet. Telnet protocol is used for the remote login. If you want to open a particular computer, another computer, or you want to access your company's computer at your home, or you want to open a particular screen of another computer in your own computer, in that case we want to use the remote login, and the remote login is provided by Telnet protocol, which is used in the application layer of TCP/IP model. Nextly, we have the SNMP protocol. SNMP stands for Simple Network Management Protocol. SNMP is used to particularly manage a particular network. Next, we have the protocol that is the DNS. DNS stands for Domain Name System. Everybody knows that the human understands the English language and the computer understands the 0 and 1. That means the computer understands the particular IP address and human understand the particular website. For example, www.facebook.com. So to convert the particular website into particular IP address, to generate the IP address from a website, or the reverse, vice versa, is done by the domain name system. Domain name system is of two types, that is the generic domain as well as the country domain. For example, we are having the particular website of like .in, that is for India, IN for India, .uk, that is for United Kingdom, that is comes under the country domain of the DNS, and the generic domain. For example, we have the website just like .com, that is for commercial, .org for the organization, that's come under the generic domain. So the domain name system divided into two parts, generic and the country domain. So that's all about the TCP/IP model. In the TCP/IP, we have discussed the main four layers, that is the host network, the combination of physical and data link, then the internet, that is the replacement of a network layer, then the transport layer, same as the OSI model, then we have the application layer, which is a combination of application presentation session layer of OSI model. We have the various features in the TCP/IP over the OSI model, as the OSI model is used for telecommunication and TCP/IP is mainly used for the internet. Because in the TCP/IP we have the two main protocols, that is the TCP and UDP. TCP for connection oriented. For example, we have any cable media like optical fiber, right? These are comes under the TCP/IP. And then talking about the wireless, just like the Wi-Fi, they come under the UDP. So that means TCP can control all the media of the wired as well as the wireless. So that's all about the TCP/IP model. Thank you.